Let's get started with part 2 of Lab 6, where we're going to look at stream flow efficiency. And efficiency has a lot to do with how much drag or friction is put on the stream by the channel which is holding it in place. So in this first example here, we're going to use a measure of flow efficiency called the hydraulic radius. And the hydraulic radius is calculated in this way here. We're going to divide the area of the stream channel, the cross-sectional area of the stream channel, by its wetted perimeter. And we can see what wetted perimeter means in just a second here. We're going to once again compare 3 different channels. So here's our channel A. It has a depth of 1 foot and a width of 9 feet. And when we're calculating wetted perimeter and hydraulic radius, we don't count the top part because that friction with the air is pretty minuscule compared with how much friction we get with the sides of the channels and the bottom of the channel. So let's go ahead and for channel A, let's go ahead and do this calculation. So the width of that channel is 9 feet. The depth of that channel is 1 foot. And if we multiply those two to get the area shown in gray here, the cross-sectional area of the stream channel, we would get 9 square feet. Now what about that wetted perimeter? That's going to be everywhere where we see a black line here. So this is the area where the water is in contact with the stream channel, and there's a lot of drag on the water at that place because the stream channels tend to be very rough, not like a smooth pipe. So we have to count up this area. So this channel is once again 1 foot deep plus 9 feet wide. That gives us 1 plus 9 equals 10. Plus again, it's going to touch on this other side over here too. So 1 foot high on this side. So altogether, we're going to get a wetted perimeter of 11 feet. And then to calculate the hydraulic radius, we just use this formula here. We divide the area by the wetted perimeter, and we're going to get a number somewhere around 1. And that's going to tell us how efficient it is. And a larger value of hydraulic radius is going to mean that it's more efficient. So we can't compare these yet, but we can certainly calculate the first hydraulic radius. That's going to be 9 divided by 11, and that's going to equal 0.82. And that's going to be square feet divided by feet would be feet again. So you're going to do that for each of these, and then just by comparing how big this number is here, the hydraulic radius, you'll be able to compare how efficient the flow would be in these 3 different channels here. And then in the end, you'll also compare this with information you're given on a semicircular channel.